Alright, so we're going to pick up kind of right where we left off. We're going to look for problem 2 now. This is the even Fibonacci numbers. So kind of the same way I approached problem 1, we're going to do the same thing here. So Fibonacci number is a number that adds the previous two. So like, first of all, Fibonacci numbers should start at 0, 1, and then you add here, but whatever, we're going to start at 1. So you would, the first Fibonacci is 1, second 2, so the following would be 3, because it's 2 plus 1 is 3. So 2 plus 3 is 5, that's the next Fibonacci number. 3 plus 5 is 8, so that's the next Fibonacci number. 8 plus 5 is 13, and so on. It goes like that. It's actually really closely related to the golden ratio, which you find everywhere in the nature. It's pretty cool that that number correlates that way. Another fun fact is similar to Abraham Lincoln, Fibonacci never told a fib. He was a famous Italian mathematician who never told a fib. So that's, and Nachi is Italian for not saying. So that's where you get the term Fibonacci from. Don't Google that. Just take my word for it. So, okay, so each new term in the Fibonacci sequence is generated by adding the two previous terms by starting with 1 and 2. The first 10 terms will be this. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even value terms. So basically we just got to get all the Fibonacci sequence numbers and then go through every one of them. If they're even, then we find the sum of all those even numbers, which seems easy enough to do. So let's get started here. This indentation is going to bug me. Even my tab size is kind of off. Okay. So first we'll start with the array, because that is how this is all built. No, they have us starting at 1 and 2, which, whatever. My first idea is to kind of do a times method. I'm going to try to get the first 10 like I did before here and there. See how that works. So to basically do this, what we have to do is push into the array the previous 2 in the Fibonacci sequence. So this would be fib array and int. So int in the first iteration is going to be 0. So that would be number 1 here on line 8. And then we need to add int plus 1. So that's going to be 2. So this would make push in another integer into this array, but it'd be 3 because 2 plus 1 is 3. So when it gets to the next one, and so on. So we can do that 10 times. And we want to, first I just kind of want to see what the array is giving us right now. So I'm just going to call this even numbers. Okay, great. So 1, 2, 3, 4. 1821 plus 13 is 34, 55, 89, 144. Okay, so we're getting the right Fibonacci sequence. And it's going to be easy enough to get the even numbers. We can just do a quick select method with that. But what I'm worried about is the Fibonacci sequence whose values does not or do not exceed 4 million. And I don't know how I would figure out when this would be 4 million without like Googling it or searching it or something like that. So that's be tricky. I'm just going to do this now because I'm recording. This is going to be an ugly little thing to do. It's not usually best practice to have like an infinite loop type thing that I'm going to do here. But I think it's going to work in this case because I just don't know what the value is going to be. So similar to what we just did, we're going to push in the fib array. The fib array, instead of integer, now we're doing count. And we're going to do count plus 1. That should give us the same thing. But what I want to do now is a break method if the fib array count. So this should give us a value, right? So when fib array count is 0, it's going to give us 1. Fib array count is 1, it's going to give us 2 there. When it's 2, 3, but I want it to stop when it's over 4 million, right? So that's what I want it to be, 4 million. But to do this on a smaller scale, I'm just going to do 144 for now, right? Because that's I can see this, and I can pretty much do that math closely in my head to see if we get the right information there. So now that we have pushed all the values into this fib array that are under 144, we need to return the even numbers, the sum of the even numbers there, right? Let me do one that's easier math. So like 2, 8 is 10, be 44. Does that be 188 if I'm doing it right? All right, this is fine. So we're going to do a select method, which is like a Boolean. It will return true if this case is true. Not saying that really right, so I'll just do a better job of just like showing you something right here. So I'm going to have an array that equals 1, 2, 3, 4, 5, 6. All right. And basically what I want to do is a select method that only returns the even number. So this will make a new array of just the even numbers. So I'm asking the question as it's iterating through, is this even? Right? And so it should return me an array that just has a 2, 4, and the 6 in it, right? Bam, 2, 4, and so we need to find the sum of the even values, which is easy enough. We did that in the last video. We do a reduce method, and this should give us a quick sum. So our sum should be 12, right? 6 plus 4 is 10, plus 2 is 12. So that is what I'm going to do here. Only problem I see is this can be taking a lot of computing power when I'm doing something up to 4 million, especially when I'm trying to come back into it. So I'm not sure exactly how long this is going to take. Uh-oh. See, this is what happens when you get the free versions and you're poor and you don't want to pay for all the stuff. You get little things like that. So we're going to do even numbers. and 188. Kind of predicted here. So 144 plus 34 plus 8 plus 2 should give us 188. So we're on the right path. Our method works. So now we got to do it for 4 million. Since I'm not super good, that's hundreds, thousands, 4 million. All right. Let's see if we got it right. Okay, so we got 4,613,732, and lo and behold, the number is 4,613,732. Great, so we got that right. Thank you for watching, and until the next video. Bye!